Bismillahirrahmanirrahim. I am Professor Jamil and you are watching YouTube channel. Today we are going to solve some problems about Laplace transform, and here is your first question. Question number 1. Find Laplace transform of these 6 functions. These 6 where k is a constant. Wherever k happens to be, it will be treated as a constant. And we need to find Laplace transform of these 6 pieces of this question. And let's start. First, solution to problem 1. And here we need to find the Laplace transform mean L of the constant k. Now, Laplace transform in general for any function of t is equal to the t variable. Since you understand, Laplace transform is an integral transform, and in integral transform we transform a given function of a variable, for example t, into a new function of a new variable. So your old variable like this t vanishes, and it means it should be integrated. Therefore, you will write integral over t, and in Laplace transform, you know integration is one-sided, mean on the positive side of the x-axis. So it is from 0 to infinity. Then integration is over t, mean dt, into kernel, and kernel for the Laplace transform is minus st, where t is the old variable and s is the new variable. S is the new variable, and this variable is of which type, the solution of this integral will tell you, and into the function ft, right? Therefore, L of the constant, mean Laplace transform of the constant, will be from t0 to t infinity dt e to the power minus st into ft is your k. Since k is a constant, so this can be taken out of the integral sign, meaning in front of the integral sign, like this, and 0 to infinity dt into e to the power minus st. And when you integrate, the integral of the exponential function will be minus st divided by derivative of the exponent, and derivative of the exponent with respect to t will be minus s, and the limits are from 0 to infinity. Now apply these limits. K into, first t will be replaced with infinity minus the lower limit, and e to the power minus s into 0 divided by minus s. And next, look, this variable was new and we know nothing about this, but here you have some condition on s. How? Look, if this s is negative, then negative value of s will make this negative plus, and plus any number multiplied with infinity will produce e to the power positive infinity, which will be infinity, and infinity divided by any number will be infinity, minus any number will be infinity. So the total answer will be infinite, mean this integral will be divergent. This we do not need. We need finite answers. This is a definite integral. Definite mean it's a convergent integral. Convergent mean it should produce some finite answer, unique and finite answer. So this s cannot be negative, and if this s is positive, then this minus sign will stay here, and whenever positive number is multiplied with the infinity, you will get infinity, and e to the power minus infinity will be 0, right? So Laplace transform of constant k is equal to k into e to the power minus infinity is 0 divided by minus s minus e to the power minus 0 will be 1 divided by minus s, and here you have the condition that s is greater than 0. So the new variable about which we know nothing, now we know something about this, that this s should be greater than 0. And look from here, s cannot be 0. If s is 0, then 0 over 0 will be indeterminate form, and this we don't need. So s is greater than 0, it is not 0 or negative. Now you make a little simplification. So Laplace transform is, this minus minus will make plus, it is k by s. 0 plus 1 over s will be 1 over s and multiply by k. And you have the condition that s is greater than 0. This is the Laplace transform. Look, this is the function of s. It's a new function of a new variable, right? And you should remember it because it will accelerate your other problem which are of some more difficulty or whose difficulty level is somewhat higher. For example, you need to use this formula. I write it in the form of a note. For example, if you are asked to find Laplace transform of 1, constant 1, then it will be 1 over s. Laplace transform of minus 4, for example, it will be minus 4 over s, where s is certainly greater than 0, etc., etc. So this is the Laplace transform of constant number k by s. So number is a constant, but its transform is not a constant. It's inversely proportional to the new variable s. Now we have question number 2, e to the power kt, and here you move. This is solution number 2, and you need to find Laplace transform of e to the power kt. Let's find. First write the general formula. Now you should be able to write this directly like this. Look, e to the power kt. Your function depends on t, so it should be integrated. So this is t from 0 to infinity and integrated into kernel, which is e to the power minus st. T is your old variable and s is new variable, multiplied by f, the function whose transform is to be calculated, and this is e to the power kt. Now simplify this integral. This is 0 to infinity dt, and this exponential will simplify e to the power minus st plus kt, and in the next line t0 to infinity dt e to the power minus s plus k into t, and so the integral will be e to the power k minus s. Minus s plus k can be written as k minus s divided by k minus s, and the limits are from 0 to infinity. And on the left hand side you have Laplace transform of e to the power kt, right? Now you apply the limits first, and let's see what we get now. Laplace transform of e to the power kt equal to, apply this limit t for infinity here, e to the power k minus s into infinity over k minus s minus the lower limit. This limit t0 will be replaced here, so it is e to the power k minus s into 0 over k minus s. Now look, if this k is larger than s, or you can say s is smaller than k, then this will be a positive number, and positive number multiplied with infinity will produce positive infinity, and e to the power plus infinity will be infinity. Infinity divided by anything will be infinity, minus anything will be infinity. So your answer will be infinite, mean this integral will be divergent. This is the integral which is going up to this point. So you do not wish to be this integral divergent. We need to keep it convergent, since this is a definite integral and every definite integral has a definite answer, mean finite answer, finite and unique answer. That's why the s cannot be smaller than k. However, if s is larger than k, if s is larger than k, then this bracket will be negative. So any negative number multiplied with infinity will produce minus infinity in the upside, meaning the exponent. So e to the power minus infinity will be 0 over k minus s minus this e to the power 0 will be 1 divided by k minus s, and this happens to be when this s is larger than k. Again, look, when we introduce the new variable, we know nothing about it. But when we solve the integral, then we know something about the new variable. And what we know now, that this variable should be greater than k. Whatever k is, this s will be larger than k. Now simplify this a bit further and you will get Laplace transform of e to the power kt is equal to, this is 0 and this minus multiplied in the downside will produce 1 over s minus k, where s is larger than k. So this is your answer for the second question, and this is extremely important result. You need to remember it also. If you remember it, then other questions of higher difficulty level will be handled very efficiently, right? So e to the power kt has Laplace transform 1 over s minus k, and remember this s is greater than k. I am going to write a note for it so that you can know how to use it. For example, Laplace transform of e to the power iota t, what it will be? 1 over s minus iota. Laplace transform of e to the power minus at, what it will be? 1 over s plus a. If it is plus k, here is minus k. The opposite sign happens here. So this is minus a and here you will get plus a. Similarly, if you have Laplace transform of e to the power minus 4ix, for example, you have variable x, but you know the variable vanishes in the final result. In the final result, you have the new variable. So be here t or x, the result will not change. So it is 1 over s minus, and in place of this k, you have minus 4i. So here you put minus 4i and the result will be 1 over s plus 4i, etc. So this is how you use it, and don't care about when you use this formula directly, then this variable t does not appear in the final answer. So in place of t, if there is x or any other variable, the formula will remain same. This is very, very important. For example, this sine hyperbolic kt can also be written as sine hyperbolic kx. This can be written as sine hyperbolic k alpha, and so on, so forth. Right? Let's solve the problem and see the dumminess of this variable. In the Laplace transform, the variable of the function is a kind of dummy variable. It can be named with any symbol, t or x or anything else. So now you need to find solution to your question number 3, right? And here you need to find Laplace transform of sine hyperbolic kx. I have changed the variable here. Instead of t, there can be x. Since a sine hyperbolic function can be expressed in terms of exponentials, so we write this in terms of exponential instead of using the integral for the Laplace transform operator L. Let's check. L of sine hyperbolic kx will be equal to L of Laplace transform of sine hyperbolic. Sine hyperbolic is e to the power kx minus e to the power minus kx divided by 2, because sine hyperbolic theta, you know, is e to the power theta minus e to the power minus theta over 2, and in place of theta you have kx. So this is the result. Now this denominator can be separated like this. Laplace transform of 1 by 2 into e to the power kx minus 1 over 2 into e to the power minus kx. Look, this is a constant multiply with function, another constant multiply with function, so you can use linearity of the Laplace operator. Let's check. Using linearity. What is the linearity? L alpha f1x plus beta f2x, and this is equal to alpha into L of f1x, mean Laplace transform of f1x, and next plus beta into Laplace transform of f2x, right? This is known as linearity property of the Laplace transform operator L. And in place of alpha you have 1 by 2, and f1x is e to the power kx, and in place of beta you have minus 1 by 2, and f2 is e to the power minus kx. So what is the result? The constant comes in front of the Laplace operator, mean on the left of the Laplace operator. So use this. Therefore, Laplace transform of sine hyperbolic kx is equal to 1 by 2 into Laplace transform of e to the power kx minus 1 over 2 into Laplace transform of e to the power minus kx. This is minus kx. Now, you know the Laplace transform of the exponential, right? So, using the Laplace transform of the exponential, what you get? Laplace transform of sine hyperbolic kx is equal to this 1 by 2, and the Laplace transform of the exponential is 1 over s minus k, right? Here if you have plus k, then in the transform you have minus k, minus 1 over 2, 1 over s minus, you have minus k, so this is minus k, right? And you have 1 by 2 common, and 1 over s minus k minus 1 over s plus k, and 1 over 2, take the LCM, s minus k, s plus k, s minus k cancels, s plus k, and minus s minus k, and look, plus s and minus s will cancel, minus k and minus k will make plus k, and this k will make 2k, so it is 2k over s square minus k square. This is a minus b into a plus b, it is equal to a square minus b square. This 2 will be cancelled, and therefore Laplace transform of sine hyperbolic kx is equal to 2 will be cancelled, and you have k over s square minus k square. And you know, when you use this transform, then s is greater than k. When you use Laplace transform of the exponential, then in the formula your s is larger than k. And here mention it, S is larger than K. This is the Laplace transform for sine hyperbolic Kx. Now, answer is there. Next, there is question number 4 and it is for cos hyperbolic K alpha. Look, this is now solution number 4 and you need to find in place of sine the cos hyperbolic K alpha. Here is alpha. And in place of this sign you have again cos. Laplace transform of this is K alpha. Alpha is the variable now. And here you have K alpha and minus K alpha. Because of this now theta is K alpha. And here again the cos alpha, cos hyperbolic will be 1 by 2. This is in place of x there is alpha variable. And using the linearity again, this, and you can name it a new variable capital A and capital B so that your alpha does not confuses with this. And this constant comes in front of A and this B comes in front of, the operator L, A and B comes in front of L. Now, in place of capital A, you have 1 by 2 and in place of capital B, you have minus 1 by 2. So, using this, sine hyperbolic K alpha, here you have K alpha and here you have K alpha and here you have K alpha, right? And use this formula, 1 over S minus K, this K. Alpha vanishes from the calculation and similarly minus 1 over 2 the same result and S greater than K. Now you have plus sign instead of the minus sign. This is my plus sign. Formula for the cos hyperbolic is e to the power plus e to the power theta plus here again cos hyperbolic theta is this one. Now you understand there is a instead of minus there is everywhere plus sign. And here you have plus sign and this will make 2s. K will be cancelled now and in place of the sign you have cos hyperbolic K alpha. Here is K alpha and your answer is K over S square minus, and instead of K you have now S. So this is log of Laplace transform of cos hyperbolic K alpha. And this is very similar to the previous result. There is a change in numerator only. In place of K you have S. Now let's have this one. For example, here the variable is U for example and here is the variable V. Wherever the variable, since then you take the transform, the variable, old variable vanishes, so it can be named with any symbol. Now, let's find this Laplace transform for the trigonometric function sine. Here in number 5, you need to find the Laplace transform of sine of Ku. And since sine function can also be written in terms of exponentials, so we do it because we know the Laplace transform of the exponential. So let's do. Take Laplace transform of sine of Ku and it will be equal to Laplace transform of sine function e to the power I theta, and theta is your Ku, minus e to the power minus I theta, and theta is Ku, divided by 2I. Let me mention the result also, because sine theta is equal to e to the power theta, I theta minus e to the power minus I theta over 2I, and in place of this theta you have Ku. So this is Ku divided by 2I here. Now separate the denominator. Sine of Ku is equal to Laplace transform of 1 over 2i e to the power I k u minus e to the power minus I k. Sorry, there will be 1 over 2i, this 1 over 2i e to the power minus I k u, right? Okay. Now using linearity of the Laplace transform operator, L, we get. You do not need to write the equation for linearity. Directly you can apply it here, because I have written it in the previous question. Sine of ku. And what is linearity? The constant comes in front of the operator. So this 1 over 2i comes in front of L, mean on the left of L, and the transform will be of e to the power I k u minus this constant again will come in front of the operator L, and transform will be of e to the power minus I k u. Now use the result. Using Laplace transform of e to the power, since you have k in your, already you have k, you can mention a new constant a, and you can mention any new variable, for example y, and what will be your result? 1 over s minus the constant, this is a, where s is greater than a, right? So when you use this result here, what you will get? Here, Laplace transform of sine of ku, and it is equal to this 1 over 2i. And now for this thing, look, your variable a, y, you can also write the variable u here, right? Because this u does not appear in the final result. So when you use this result for this piece, then a is ik. So your result will be 1 over s minus ik. So for this piece, 1 over 2i, you have 1 over s minus a, and a is your ik, minus this minus 1 over 2i, and for this piece, Laplace transform of this, a is minus ik, so the answer will contain minus ik for a. So it is 1 over s minus and minus ik, and the result is s greater than, in place of a, you have the constant k, s larger than k. Now simplify it. 1 over 2i will be taken common, and you have 1 over s minus ik plus, minus 1 over s plus ik. These two minus will make plus, and take the LCM. S minus ik, s plus ik, and this cancel, gives you s plus ik, minus this gives you s minus ik, and you need to do some more simplification. Minus s will cancel, and you will have 2ik over a minus b, a plus b. It is a square minus b square, and b is your ik now. And 1 over 2i, this 2i will cancel, and you will have k in the numerator, and in the denominator you have s square plus k square, because this I square will make minus and this minus plus. And on the left hand side you have Laplace transform of sine of ku. So this is the result for this type of transform, and s is greater than k as before. So sine Laplace transform for the sine of ku is k over s square plus k square. Now you have last question, cos of kv. This is part 6 of the question, and you need to find sine cos of kv, and this in place of sine you have cos and kv, right? And this, let me write it again in full. Instead of replacing the things, we do it quickly. Cos of kv. So log Laplace transform of cos kv, and write cos in terms of exponentials, e to the power I kv minus, in place of minus you have plus sign, minus I kv divided by 2, because cos of theta is e to the power I theta plus e to the power minus I theta over 2. And for theta you have kv. That's why here kv, and 2 is from the formula. Now separate the denominators again, and you have denominator here 1 over 2 e to the power I kv, and plus 1 over 2 e to the power minus I kv. Now use linearity again. You have a constant multiplied by function f1 plus constant multiplied by function f2. Using linearity of the Laplace transform operator L. And what is the result for this? That constant comes in front of the operator like this, mean on the left of the operator, and the transform is of the function, and this plus 1 by 2 will come in front of the operator L, and transform is of I kv with minus sign. Now using Laplace transform of e to the power a v, for example, and this is 1 over s minus a. The variable v will vanish and a is there, and condition is that s is greater than a. Use this. When you use this, then a is ik, and when you use this, then a is your minus ik. Let's use it. Laplace transform of cos of kv, and this is equal to 1 over 2 into, for this case use this formula, and in place of I use ik here. So it is 1 over s minus ik plus this plus from the formula, this 1 over 2 into 1 over s minus, when you use this formula for this piece, then a will be, this a will be minus ik. So this is minus ik, here minus ik, and s is greater than, in place of a you have k. You do not need to write iota here. 1 over 2 will be taken out, and you have ik, and plus 1 over s plus ik. Take LCM again. This is s plus ik and plus s minus ik, and this is 1 over 2. S plus s will be 2s, and ik will cancel. So this is a minus b, a plus b again, and it is a square minus b square, and b is your ik. Therefore, Laplace transform of cos of kv is equal to s over s square. This I square will be minus, this minus will be plus, into k square, and s is greater than k. This is the Laplace transform for cosine function. I hope you have some understanding that how the transforms are utilized, how the transforms are found, are calculated, and you know that you should be in your mind what is the formula for Laplace transform of a constant. It was a over s. A is any constant, and Laplace transform for the exponential. Then rest of the questions can be done quickly, right? And I will suggest you that try to remember these 6 formulas. If you remember these 6 formulas in the form of their Laplace transforms, then further questions will be solved much quickly. Thanks for watching. Keep watching and like, subscribe and share this video with your friends and family. And above all, press the bell icon when you are subscribing this channel so that more questions, more interesting videos about mathematical physics comes into your inbox in the first place. Thanks for watching.